Now, this problem for integration by parts is a bit hard, so try and keep up. Have a look really carefully at it because it is difficult. It's lots involved, so just be wary. Now, this time we've got x times inverse sine of x. So we're going to look at the idea we integrate our first, leave our second, because we can't integrate inverse sine of x by itself. So x has to be treated as our first function. And then minus integrate the first, derive the second. 1 on 1 square root of 1 minus x squared. That's not too bad. Unfortunately, though, that doesn't make it any simpler, really. Or it does make it a little bit simpler because we haven't got inverse sine of x. But it's still not an easy one to integrate. So we've got to go by parts again. So we clean it up a little bit. We get the x squared. And I break it up to be this. Because I know, again, as we've seen before, the minus x over the square root of 1 minus x squared can be integrating nicely to 1 minus x squared all squared, or the square root of 1 minus x squared. So that's a nice one to be able to integrate. Because we integrate the first, leave the second, and then integrate the first and multiply by the derivative of the second, which is 1. So that's nice. Until we get to this point, then we realise we have to integrate the square root of 1 minus x squared. Now that's not so easy. So what we've got to look at here is doing an integration using a substitution. So, and it should use a trig substitution here. It's square root of 1 minus x squared. So we know that we can start to manipulate it here by putting a sine of u in for x, and then dx would be cos u du. So take the square root of the cos squared u, which is cos u times cos u, gives us cos squared u, which we can manipulate to give us that, then integrate. So that would give us u when we integrate, which is just inverse sine of x, and a half sine 2u, which we need to still manipulate because we need to write that as 2 sine u cos u. And to put, because we had x was equal to sine of u, well, we know sine of u is x. But what about cos of u? What would that be equal to? Well, if that's in a triangle and sine of u is equal to x, which is x on, we could write it as x on 1. So opposite, hypotenuse, our adjacent becomes 1 square root of 1 minus x squared. So cos of u must be square root of 1 minus x squared on 1, which is, that's our expression there, that's where we get it from. So there's our integral of square root of 1 minus x squared. Not pretty at all. That's rather ugly. So, but that's what we've got. So that's what our expression starts to come out like. So there's the derivative of that function there. And then we can clean it up. So we've got the x squared on 2 inverse sine of x, which we did originally, and this all come all the way down. And then we're able to multiply. We've got the multiplication by x there, and the half inverse sine of x, and the x times the square root of 1 minus x squared. We cleaned up with that one there. So we're able to be able to get that expression there. So look through it carefully and see how we got down to all that. It's not an easy question. There's substitution going on, lots of integration by parts. So not an easy one there. Integral of x log of x dx. So again, we can't integrate log of x, so we get a derivative, integrate the first, leave the second. And then we integrate the first, derive the second. And because of natural log of x is 1 on x, it's not too bad. The x is cancelled, gives us x on 2, which we can integrate quite nicely. This one we've got in x times the natural log of x all squared. Well, again, we have to take x as our first, which gives us x squared on 2. Leave the second. Minus the integral of the first times the derivative of the second, which would be a chain rule on this one. So 2 natural log of x times 1 on x, which comes down to integral of x log of x, which, well, that's what we just proved there. So that's why we can use that straight into that part there. So the x squared on 2 natural log of x all squared comes down, and we're integrating by parts again on that part to get down to our function there. X squared times natural log of x. So again, because we can't integrate natural log of x, we've got to integrate x, so it becomes x cubed on 3, natural log x. And this one again, that would cancel, so you get a 2 there, and that one cancel. Just x squared on 3, which integrates to x cubed divided by the 3, gives us that one. So you can see we can play around with the actual logs there. Sometimes easy, sometimes not so easy, as you can see there. And what might look like is going to be a function will work out hard, and vice versa, depending on what we've got. So the area you take as your first and your second, as I said, sometimes we're limited, as we saw in those questions, we were limited what we had to take as our first and second there. So just keeping that in mind and try to manipulate it down as easy as possible.